Okay, so carrying on from where we left off with this MonoGame project, we have all this code to draw a game frame, and it's all inside our draw function. But what I'm actually going to do right now is refactor it all, apart from that base draw, because that's, as I say, that's one of the things you don't want to mess with. So if I highlight it all, right click, go to Quick Actions and Refactorings. The only thing we should be able to do with it right now, is it not coming up? Come on. We should be able to do a refactoring to extract it, but it doesn't seem to be liking it for some reason. Oh, it's still running. That old chestnut. So highlight that all, refactor. Yeah, it's extract method. So as usual, you get a preview of what's going to happen. We'll put a new method call in here, and the new method that's created will contain all the code you've got highlighted. So if we click extract, and I'm going to call that draw startup, because we're going to have a startup screen and a gameplay screen, and they'll be separate. That's why I'm doing this. So type that in, press enter, or click apply. So now the MonoGame draw function just calls up draw startup, which contains all of our old code, and it passes the game time along down so that it can be used. And there we go. Now the reason for doing that is I'm going to put in an enumerated type. So enum, I'm going to call this enum game state. There's going to be two game states in my game called startup and gameplay. So I guess we'll stick to camel case, I think. So we're going to make a game state called the current game state. So this is which state we're currently in. And at the start of the game, we'll be in the startup screen. So what we're saying is that we have a current game state which is set to startup, but could later be changed to gameplay if we choose. So back down to our draw function. Let's close down, minimize rather, draw startup. And in our draw function, we only want to draw the startup if our current game state is game state.startup. So that line of code, that function call there, which runs all of this stuff, only runs if we're in the startup screen, which I've just said already we are, so nothing's going to change for the moment. But now we have the option to switch to the gameplay screen should we wish to. And that's the sort of thing that's done in the last function that I'm going to show you, which is the update function. So update at the moment only has our quit button built in. I think I'm going to simplify that a little bit because it's kind of big and we're not using a gamepad. So let's take out the gamepad stuff. And I'm also see this keyboard.get state. What I'm going to do is cut that from here. We'll make a keyboard state variable called key state. And that's going to store the status of the keyboard for us. So we won't have to call that function over and over for different keys. It's just a little bit more efficient. So our keyboard state, we're going to get from the keyboard object. So access the keyboard object status, save it for later so that we can use it for more than one thing. Simplifies the code, also makes it a touch more efficient. Okay, so if key state for escape is held down, then exit the game. If the key state is such that the key is held down for the space key, then that's going to do something different. So that, right away, you see I'm not having to duplicate that in here. But if you press the space key, then our current game state will change. Oops. Will change to the gameplay screen. So as soon as you press space, it'll switch out of the game startup screen, so it will no longer run this code. Let's see if that works. Start up in the startup screen, changing colors randomly. If I hit the space key, it should stop because we're no longer in the startup screen. So it's no longer running the code to change the color. Okay, what else can we do? Well, there's our, I'll put in brackets. It's probably just good practice really to have curly brackets for that code there. So if you press space, switch to gameplay, and in the draw method, if you're in the startup screen, draw the startup. But if you're not in the startup screen, that's what else is going to say. And by the way, notice that I do not do this. We don't check if you're on the other especially don't do this. We don't check if it's the opposite of the first condition, because that's implied. If that condition is not true, then it must be false. There's no need to check it a second time. So although that won't cause any problems, that's a waste of time. Don't put that in. It's implied in the word else. Anyway, so if you're not in the startup screen, then don't draw the startup. Instead, draw gameplay. And that's a function that doesn't exist yet. So let's click on potential fixes, generate the method for us. There it is down there. All that will do is throw an exception. So we don't really want that to happen. Let's take that out. But it's made our method for us. And we'll put in graphics device.clear. That's very similar to what happens in the update screen, graphics device.clear there. But we'll have a fixed color for the gameplay. Let's make it a black background for gameplay. So now, instead of just stopping the interpolation of colors, when you switch to the gameplay screen, you'll just get a black background. We can do the same thing for the update. I would leave in the base update, and also I'll probably leave the keyboard state because that's something you'll need for every screen. But the rest of it, I don't know, maybe you want to leave the escape key in, I don't know, it's up to you. But you certainly, this space bar is something that should only happen during the startup. So I would right click on that, extract it to update startup screen. But we only do that, again, if we're at the current screen of the startup. Otherwise, we'll want to update gameplay. And again, that's a function that doesn't exist, so let's generate it, take out the exception that it generates for us. So now we have we've got 3 updates and 3 draws. Let's minimize everything. We've got 3 updates and 3 draws. So the main update just switches between one of the other 2 depending on what game state it is. And the main draw switches between the other 2 draws depending on what the game state is. So that will handle states for us on a very general level. There's more to it than that, of course, by quite a margin, but that's the basic idea of game states, and we can switch between 2 different screens in our game. Right, so let's get started. Actually, we're not quite going to make the game yet, actually, because that startup screen's not finished. But let's get started rendering stuff to the screen. Now, to draw stuff onto the screen or render it, we need to have something in memory to actually draw. And if you put a file on the hard disk in your project, it's not in memory yet, so we need to load it from there. But even then, we don't have any graphics yet, so let's get the graphics into our project. Now, there's a thing in here called the content folder, and that's got a file inside it called the content.mgcb. That stands for MonoGame Content Builder. Now, what's meant to happen is you double click that and it will load up the MonoGame Content Builder pipeline, but quite often it doesn't. You can see all this garbage here. Let's close that out, otherwise it's going to cause it. In fact, no, I'll leave it open so you can see what little pop-up it does. Nothing too serious, but to fix that, you're very likely to have to do this. You right-click and do Open With, browse for the pipeline in there, and click OK. If that doesn't work, you may have to add another link to the content pipeline, which you would browse for it in the program files, and then you go to MS Build, MonoGame version 3 tools. It says 3.0 by the way, but it isn't. It's 3.4 or 7 or whatever. There's the pipeline there if you ever have to do that. But hopefully that one there will be okay. You just click, oops, sorry. You can just click on pipeline and hit OK. And there it is. That's the actual MonoGame pipeline. So it's a separate window for loading your content into. Please do not do File New. That will make a new content builder pipeline. Don't do that. Instead, use the Edit button and add a new item or an existing item. You can also right-click and do it from here, Add New or Existing Item. And that's what I'm going to do. I'm going to grab an existing item from a project very similar to this one that I did earlier. So grab an existing item. I'm going to go back to my original version of session 7. And there's a title screen there. So when you find a graphic, it handles PNGs and JPEGs and a couple of other things. But when it finds it, you have the option to copy it or add a link or skip adding the file. Skip obviously does nothing. Do not add a link because, or well, I recommend you don't add a link because what will happen there is it doesn't put the graphic into your file. It puts a link to the graphic into your file, into your project rather, and that's all kinds of headache. You move your source folder around, your project stops working. Rename something, your project stops working. It does have the upside that you can edit the original graphic and then the game will change, but that's pretty minor. I would always copy the file to the content directory, that content directory there. So click OK, and it goes. And then if we save and close out the content pipeline, there's the pop-up I was talking about earlier. Because the content pipeline was already opened here, it says this has changed outside the editor. Do you want to reload? And you should just say yes. So you can see there's the changes that have actually been made by what I've done. But you don't really want to see that. Let's close that down. Little tip, by the way, see if you click this button here, show all files, you can see title.png is actually in there, and there's our actual title, which I'm going to draw on the screen. So if you want to preview them, that's a nice way to do it. Okay, so how do we get that onto the screen then? Well, and it's another member variable we're going to need, and this time we need a texture 2D variable. There are texture 3D variables, they might not be what you expect them to be though. Texture 2D is what we're going to use from now on. So I'm going to call that background image. And that should usually be handled by load content, which we've not really touched yet much. So load content is when you load graphics from disk, and that's exactly what we want to do. Take the background image and assign a value to it. The contents of the background image texture are going to come from our content pipeline. Tell the content pipeline to load a graphic. Now when you do that, it's a generic method. That angle bracket T tells us that. So we need to put in angle brackets and tell it what type of object to load. You can load in sound effects, you can load in songs, 3D models, and texture 2Ds. We're not done yet though. You need to tell it what is the name of the thing that you're loading. What was it again? Title. Oh, notice it's title.png, but when the content builder builds it, it leaves off the PNG on the end. So just put in title. So that will load it from disk into memory, but not onto the screen. That's the next thing. So we want to draw this during the startup. So after we've cleared the screen, next thing we do is get the sprite batch to draw our sprite. So if you open the brackets there, you'll see the parameters we need. And there's actually 8 versions with different parameters. So I'll look at them in due course. But for now, we need a texture. Let's actually pick this one. A texture, a vector, and a color. So the texture we're going to draw is background image. The vector is going to be a new vector, which I'm going to create right now with the values 0, 0, top left corner of the screen. And the color, that's actually optional, but if you do put it in, make it white, because the color it does change the color of the thing, but it doesn't change it to that color. It's almost like shining a torch of that color onto the object. So if you shine a white torch, it's going to come back normally colored. If I put color.red, then it's like tinting it with a red shade. It might not be what you expect. So it can sometimes be useful, but most of the time you want white in there. Now, that is not going to work. I'll show you what happens if you just do that. It'll reach that line of code, and then you get a runtime error, an exception, invalid operation. And look at the additional stuff here. Draw was called, but begin has not yet been called. Begin must be called successfully before you can call draw. Let's stop. What that's saying is we need to do this sprite batch.begin. So begin the batch. Start collecting sprites to draw on the screen. When you're finished, end the batch, and that will flush the sprites out onto the screen. Let's run that. And there we go. There's our logo appearing on the screen with the changing color background. But that was at position 0, 0. You can reposition that by just changing these values. But let's take it one step further, and we'll make a vector2 variable. So along with our background image texture, let's make a two-dimensional vector. Notice it's not vector 2D, just to be inconsistent, but never mind. So a vector 2 called background position, and we'll start that at an x coordinate of 0, so it's not moved left or right, but we'll move it down the screen a bit, 150 pixels down. Notice that going down the screen is a positive number. If I put a minus sign in there, it would be further up the screen, which might be the opposite of what you expect, but screen coordinates are just, the y is reversed in comparison to Cartesian coordinates. Anyway, that's going to be our position. Let's copy and paste that in our draw startup as the position where we're going to draw our background image. So that should reposition it. But now, because it's in a variable, we can move it around. We could have it player control, but that would be a bit weird for menu. Instead, we're going to do some deterministic movement, which means the position is going to be determined by the actual time. One way to do that would be take our background position and change its x coordinate. We're going to use the math library. We're going to get the sine function. I'll tell you why in a minute, but see if we get the game time, which we saw up there before, and the total game time. So that's not how much has elapsed since last frame, but how much time has passed since the game loaded in milliseconds. So it should be quite a large number. Let's divide it by 1,000. So you'll get that in seconds. We could have done total seconds, but I wanted to make clear that we're going to have a fractional part there. But then we'll multiply it by 20. Now, it doesn't like that because the sine function returns a double, and x is part of a vector, which is made up of floats, not doubles. So we'll have to convert it to a float. So the sine, I don't know if you know are familiar with the sine function, but it goes in a sort of wavy pattern up and down. So over time, it's going to go 20 pixels up and down every second, I think it is. Or it'll be 1,000 times. Sorry, not up and down. It's the x coordinate, isn't it? Left and right. It's going to move 20 pixels left, 20 pixels right over a period of 3.14 seconds. It would be, I guess. This is pi radians. Anyway, so that's some deterministic movement left and right. I think that will probably do for our startup screen. Now, next thing I guess we'd probably want to do is get a score on the screen. Yeah, we're going to do a sort of an egg dropping game. Now, if we want a score on the screen, we're going to have a font to draw it in. And the way MonoGame works, you need to have, oh yeah, I know where I'm going with this. Okay, cool. So it's still set to that. Right click on content, open with. Oh yeah, I should have chose pipeline and set it to default. So I'm going to add, this time I'm going to add a new item, not an existing item. And I'll make it a sprite font, call it Arial. Click OK, and it goes, Arial sprite font. You can double click it there and actually see the sprite font itself. It doesn't look like a font. It's a sprite font description. It's telling us to use the Arial font, size 12. In fact, let's make it 16. You can change the spacing, the kerning in between letters, etc. There's various options there, but that'll do for now. So that's the basic idea of a font. You can take it one further though. We could make a second font. I'm going to make one myself using a program called Sprite Font 2, which is separate, but you can download it off the web. Now, Sprite Font 2 is if you want to use a sort of fancier font. So you can still choose a font type. Let's go with, I don't know. I must have a sort of stencil one here somewhere. In fact, it's probably called stencil, isn't it? Let's go down to there. Yeah, stencil. So that's a sort of military looking one. We can change the font size. It's better to have something too big because you can scale it down more easily than you can scale it up. We can change the pen. So you can enable the pen and enable the brush. So the pen is like a stroke around the outside and the brush is the bit on the inside. You can see the preview changing as you do that. So let's make the pen color cyan. Sorry, not the pen. Yeah, we'll leave the pen color cyan and make the brush color green. Maybe a thicker pen around it. Yeah, why not? And there's other things you can do. We can go into the effects and we can make it glow. Oh no, we can make it have a shadow, which is hard to see on that background, but that might be nice. Give it a bevel effect, whatever you like. And then eventually you want to go to export. I would turn off font metrics, they're just going to confuse you. Just we care about the output file name. So click export. I must have got a file there already. I can't save over it. But there's the sprite font pre-rendered. And I'll put that somewhere else so I don't get that error. So let's call that myfont.png. Click export. And there we go. It's worked that time, no error message. Now if we go back to our content builder, we can go edit, add existing item. And there's my font in there, copy it over. Now, if you do it this way, what you have to do is look at these properties down here. It's currently set to import it as a texture and process it as a texture, which is the same as our title. But the title and font should differ because although the font is a texture, we should process it as a sprite font texture. There we go. So make sure you do that, otherwise you'll get error messages. In fact, I think I might turn that back so you can see the error message and recognize it. Okay, so close that out. So we've got two fonts to choose from now. Let's but remember, if it's in the content pipeline, you need to load it into memory. Oh, one other thing, by the way, before I forget. If you want to make sure everything's working, you can click build here, and that will build the content. You should see all of it succeed. Oh, one failed. Hello, myfont.png cannot be processed by font description. What's went wrong with that? Oh, if I clicked font description by mistake, it should be font texture. And let's build it now. Yeah, 3 succeeded. So that was nice. If I hadn't done that, I'd have got a weird error message from in here because it's not Visual Studio that handles the content. Anyway, okay, so build the content in there if you want to see error messages that mean something. And then in here, back in Visual Studio, we need to load stuff from content into memory before we can use our font. So just like earlier, we defined a texture 2D. Now we're going to define a sprite font. I'm going to call it main font. And then back to load content, just like we loaded our texture, we are going to load our font. From the same place, content.load, but this time we're loading a sprite font. Let's go with Arial for now, we can see the difference between them. And we need something to draw, so let's give ourselves a score, an integer score, equals 0. In fact, no, I'll just leave it as int score because when you press the space key would be to go from the menu to the gameplay. So update the startup. There it is, space key. Switch to gameplay screen. Also reset score to 0. So every time you start a new game, score becomes 0. Not only once, but every time you start a new game. Okay, now we're ready to draw that number to the screen. We draw it during the game, so let's draw gameplay. So there's graphics device.clear. I'm going to put in sprite batch. Don't forget sprite batch.begin. In fact, I usually put sprite batch begin and sprite batch end in first, and then stuff something in the middle. So this is the other main thing sprite batch can do, not just draw, but draw string. And you'll see it needs a font, some text, a position, and a color. There's other options, of course, but let's stick with that for now. So here's our font. It's the name of your font in the code, not the name of the font on the disk. And the text we're going to draw is the words your score is, followed by the actual score variable. And then a comma takes us to the next parameter, which is the position. And I'm going to position that at a vector to location 0, 0. And we're going to draw it in white. Okay, let's hope that works. So there's our menu, press space to start, and there's our gameplay with the score being rendered in the default Arial font. But I went to all the trouble of making that nice font. Let's use it. I called my font. So let's take out Arial and put in my font. Run it again. Space to start. Yeah, that looks a bit better, doesn't it? Okay, so now we've got a score. What are we going to do? I guess it's probably time we actually started making it something that resembles a game. Now, we're going to use a little bit of math here, but don't be too put off when I say that it's going to be integration, because integration at a basic level is nowhere near as scary as it sounds. Integration just means something gradually changing over time, and that's what's going to happen. You hold down a key, and the position of your basket that we're catching the eggs in is going to gradually change. So that is technically integration. To be specific, a form called forward Euler integration. Forward Euler. Not Euler, it's a Dutch or Belgian or something, I'm not sure, but that's the guy's name that invented it, Euler integration. But all it means is every single frame update, you add on something to our position. Position of what? Well, we don't have anything yet. Let's get a texture. And a vector for the, let's just do the following objects first, because then we won't have to worry about input controls. So our eggs image, texture, and our egg position vector. And then load content, because you've got a texture 2D, we'll need to say egg image equals content dot load texture 2D. What's the name of our texture? We don't have one yet. Let's leave that for now and go and get a texture. Again, here's one I made earlier. I'll load a bunch of them. Basket, some sound effects and music, and an egg. Okay, that's them all loaded in. I think I got these graphics from, what was the name of the website now? Let me look it up. I think I have this written down somewhere. Nope, apparently not. Okay, well, I just found them on a free website anyway, so let's see. What did I look at? Was it? You know, I'll come back to that. I'll find the website. I mean, I did just go to a free clip art website and slightly edit them to be the right size with the transparent background. But let's save it. Preview all the files there. You can see there's our basket. And there's our egg. So we catch the eggs in the basket. And that's how you get points. So how do we do that? Well, oops, what was their name again? Egg one. Okay, so that's why I was here. Egg one goes in there. So that's the name of your content to be loaded. And then in the draw method, oh, that I've just noticed where it's openclipart.org. So literally I just searched for basket, and where's the one I chose? It's in here. There it is. There's the picnic basket, and the egg was in here as well. And It's, I believe, totally free to use, so that's why I use that one. Okay, so we've got our egg image in our content pipeline, loaded in from disk into memory, ready to draw. So let's just go ahead and actually draw it during the gameplay. So there's our score. Right after that, sprite batch.draw egg image at the egg's position. You can leave the color out if you want, but I'm going to put white in because that's the default anyway. And if I haven't messed that up, we should see an egg appear at the position 0, 0. Yep, there it is. Right, I promised oil integration, or threatened, depending on your point of view. And that's the next thing to do. So, yeah, we'll need a speed. So, vector2 fall speed. I'm going to set that to have a gravity of 10 on the y-axis. So that's 0x and 10y. It's going to move 10 pixels per frame downwards on the screen. So when does that actually happen though? Because that's not baked in. We need to tell it to do that. Well, it happens during the gameplay. That's where I put that comment in. So, oops, our egg position changes every frame. This is the integration happening. You're adding on, so it's egg position add on the fall speed. I told you it wasn't anywhere near as difficult as it sounded. Let's see that. There we go, our egg falls. But that's it. Incidentally, we can't go back to the main menu screen yet, but if we did, we'd find that the egg continued from where it left off, which is not ideal. Let's when you switch to the gameplay screen, so there's a startup screen. When you press space key, you switch. So we could probably give it a new position there. Actually, I'm going to leave that for now, but definitely will need to give it a spawn point. Okay, so that's our three objects that we need for the sprite, but actually we're going to need other sprites. We may need more eggs. We'll certainly need a basket to catch them in, and they're all going to have at least a texture and a vector. So let's combine them into a class. Let's make a sprite class. I probably should make a separate file for this, but you don't have to. And just for quickness, I'm going to keep it in here. So public to every sprite is going to have a texture 2D. I'm going to call it image. Notice I am not calling it egg image, even though I know it's going to be an egg. And that's because only one item is going to be an egg. The other one's going to be a basket. So you don't want to be ending up with code saying basket.egg image, which doesn't make any sense. Keep it generic. So every sprite, whether it's a basket or an egg or anything else, you could reuse this for Space Invaders and make it aliens or whatever. Each one's going to have its own image and position. So now we can get rid of egg image and egg position and replace it with a sprite, which I'm going to call falling egg. Now that's then going to complain, oh, the egg doesn't have a position. Well, that's because we took that out and replaced it with falling egg, and it's got a position. Now it's not going to like that. We'll see why in a minute. But oh yes, and the image as well. Egg image doesn't exist anymore. It's now falling egg.image. Not major changes to be done here. It's just basic refactoring stuff. Now I think that's got rid of all the compiler errors, but oh no, it hasn't. What have I forgotten? Oh, the rendering. Yeah. So falling egg.image and draw it at falling egg.position. Don't worry about that warning. In fact, let's ignore it. Right, so it compiles, but then you get the runtime error, null reference. So this is very, very common. One of the most common types of exceptions, a null reference exception. Object reference not set to an instance. Well, something in here is null. What is it? Oh, it's the falling egg. So falling egg is null. We need to tell it that our falling egg is going to be an empty sprite. And that the sort of best place to do that is in the initialize method. Falling egg is going to be a new sprite. So now that's no longer null, it's a new sprite. It's empty, but it exists. That should get rid of that crash. We've got a position changing based on fall speed. Notice that I didn't put fall speed inside the sprite. We could put a speed in there if we wanted, that would be fine. But all our eggs are going to fall at the same speed, so I left it outside rather than duplicating stuff for no reason. Okay. So, like I said, I'm going to minimize it. It's getting a bit messy now. In our startup, we press space to begin a game. We're going to make our falling egg position. So it's going to be our spawn point. We're going to make it random. So our x coordinate is going to be random from 0 to 1000. And our y coordinate, I'm going to keep it at 0 just now. It'd be better to have it spawn off screen and come on, but let's leave it at that for the moment. So now when you press space, it's going to not drop from the top left corner, but some random point along the top of the screen. Okay, so that's basic integration. Let's take it a step further now and integrate velocity, not automatically, but based on keyboard input. So we've seen keyboard earlier. Let's go back to that. We stored it in the key state variable. We're going to make use of that to move the basket. Now the basket is going to be a sprite. I'm going to call that sprite the player. So make another sprite called player. And the first thing to do to stop any null references is to make the player a new sprite as well. And then in the load content, player.image equals content.load texture 2D. Which texture 2D are we going to load? It's basket.png, but remember you don't put the .png on. So just load the basket. It's probably a good idea to give it a position. That's the kind of thing that ought to go and initialize, but I'm going to keep it all together. And it is okay to put it here, I suppose. It's not going to fail. But our player's default position, I'm going to make it a vector which has an x coordinate of 440, a y of 660. I think that should put it roughly in the middle of the screen, if I'm not mistaken, near the bottom. Oh, maybe not. No, I've not drawn it first, of course. Yeah, another easy mistake to make. If you want to see things on the screen, you have to draw them. So we've drawn the egg. In fact, let's just copy and paste that. So we now draw the player image in the player's position, as well as the egg. Press space to start. There it is. Doesn't move yet, but it's being rendered. We've got our basket ready to catch the egg. How do we get it moving? Well, that's during the update, not the draw, because things are happening in the game world. So if you press this, oh, sorry, that's update startup, isn't it? We want update during the gameplay. Our egg is falling. That stop button is really getting annoying. If our keyboard state is such that the A key is held down, then the player's position along the x-axis is going to change by subtracting 4 pixels. If the keyboard state, is such that a key is held down on the D key, so it's A and D to move left and right, then the player position along the x-axis is going to go up by 4. So that's moving 4 pixels left, that's moving 4 pixels right, depending on which key you press. Let's see that in action. A little bit slow perhaps, but it works. And now it sort of looks like a crappy game, but it's not playable yet. We can't catch things in it. Also, if we kept on going, it would end up off the screen. I guess we could leave that in, but I'm not going to. That's annoying. So we're going to constrain it to the screen. If the player's position along the x-axis goes below 0, then the player's position along the x-axis will reset to 0. So if it goes negative, then it's going to go back to 0 immediately. So it will never stay negative. So now stops on the left hand side of the screen. But if I go right, I haven't got any code to stop it going off the right hand side of the screen. And that's just a tiny bit harder, because the right hand side of the screen, although it is 1366, remember we're not supposed to put that number in, we're supposed to put screen width. And if I just put that in, it's not going to be quite right. Watch what will happen. So it will stop you at that pixel, but that pixel is the edge of the screen. So you go exactly just barely off the screen and no more. So what we need to do is, but the reason for that is because the position of the object is 0, 0 on the left-hand side of the screen. As it goes further to the right, if it reaches an x-coordinate of 1366, then the first pixel of our basket will be the last pixel of the screen, and it goes off the screen. So what we should do is bring it back by the player image width. Put that both here and here. So now it's saying don't go past that pixel of the screen instead of that pixel. And it stops it. It's now constrained on the left and the right hand side. Okay. Let's take a slight detour before we go ahead and do the collision. Let's put some sound effects in. Put all these sounds in. Let's use one of them at least. So I'm going to have a sound effect object. Call it begin sound. Oh, it doesn't like sound effect. Let's put in the using command for X in the audio. So we're going to have a begin sound, and as you might imagine, back to load content to actually load that. So begin sound equals content.load. We're going to load a sound effect, and what was it called again? Begin. Oh, of course it is. So we load in the sound. It doesn't play as soon as it loads. You have to decide when to play that sound effect by you just typing in begin sound.play. So when should we do that? Well, the begin sound should play when you switch to the gameplay screen, and that happens when you press the spacebar. So begin sound.play, and that's a method, so it needs parentheses. Volume not on. I'm not hearing anything there. It could be coming through my headphones. Oh, it is. Right, so let's change it to the speakers. Still nothing. That's weird. Let me check that actual sound effect. In fact, let me check the speakers first. Yeah, you can still hear that. Begin sound. Actually, it seems like my sound effect is gubbed. Okay, let's make a new sound effect. So I made it using something called SFXR. I think there's an online version called BFXR. It's not quite. We need to get Flash, and I don't really like Flash running anymore. Let's see if I can find a copy of that somewhere. I think I've got some portable apps here somewhere. Sound effect generator. There it is. I'm still not hearing it. It's coming. It is coming through the headphones. That is annoying. I don't know if you'll be able to hear this then. Maybe I can change the default output. So for playback, the speakers should be the default device. Let's see if that helps. There we go. Okay. So there's our sound effect. The actual code for that was relatively simple. It was the speakers that were annoying. But okay, so that's how to play a sound. It's make sure you're careful when to play the sound. If I put that in here, I'm going to turn down the volume for this one. Yeah, pretty horrible. Because it's trying to play it every single frame 60 times per second. So make sure you put it in only as a response to a thing happening, which would be inside an if statement. Okay, so that's a basic sound effect. Before we start catching the egg, once we catch it, it'll just disappear. So let's put in a way to make it respawn. Update gameplay, I guess that is. There we are, falling egg position. So the egg moves down the screen. If the falling egg's position on the y-axis goes beyond the height of the screen, so this is all actually technically just off the screen, but that's what we want in this case. When it goes off the screen, then the falling egg's position is going to be another new vector, rng.next, so a random x coordinate, but I'm going to make it minus 100, so it's a little bit off the screen. That line, by the way, that's very similar to the line I used earlier. It might be better in the long run to refactor that out, but I'm going to leave it there just now. And let's see, there it goes. It's raining eggs. Hallelujah. Something else you could do, by the way, I don't have a gamepad plugged in just now, and even if I did, I couldn't prove it. But you can use a gamepad instead of a keyboard. It's very similar to the keyboard state controls. You would just say something like, gamepad state, I'll call it pad, and we'll get that from the gamepad state. Oops. So just like the keyboard object, there's a gamepad, sorry, an object class, just like the keyboard class, there's a gamepad class, and you can get the state of the gamepad at that moment. The difference is you need to choose a player index, because there could be up to 4 of them attached. Now, if that pad, look at it, you've got the D-pad, you've got the buttons, you've got the thumbsticks, you've got the triggers. I'm going to use the D-pad. And if you hit the dot, you've got up, down, left, and right. So you can choose different buttons. They're not booleans with true and false. You need to compare them to the button state, which you kind of saw briefly earlier. But if the left button is pressed, then player's position on the x-axis goes down. And if the right button on the D-pad is pressed, then the position on the x-axis will go up. So it's very similar to the keyboard. I thought the keyboard controls a bit slow, so let's make them consistent, 8 pixels instead of 4. So now you can use the gamepad or the keyboard. Slight note, if you leave the code in for both, then you can control the basket with both. And if you hold down the left button and the A key on the keyboard, you can actually go twice as fast. So that's something to keep an eye out for. Multiple control systems need to be quite carefully monitored. If you want to use the thumbstick, it's not a button, so it's a little bit different. You would say if the pad.thumbsticks, choose a thumbstick left or right, and then thumbstick is a vector, so because you can move it along, you can move the thumbstick left and right. You can also move it up and down. So let's get the left and right position of the thumbstick, and that is a vector made up of, come on, can we get the x? Yeah, we go. The x is a float. Now, that float goes from 1 to -1, with -1 being all the way left and +1 being all the way right. So if it's more than half on the minus scale, so it's more than halfway to the left, then player position x changes to the left. And if it's more than halfway to the right, so it's greater than a positive, then move it to the right. Not that different either, really, but you just need to be aware that the x the vector contains an x and a y, and they go from 1 to -1. So that's if you want to use gamepads. I'm going to take that out, but the option is there if you fancy it. Oh, sorry, one last thing before I do though. Another way to use the thumb pads, because they do vary from 1 to -1 as floating points, you could simplify it. You could say take the position on the x-axis and add on 8 times pad thumbsticks left x. So that number, how far you're holding the left thumbstick to the left or right, +1 or -1, become +8 to -8, and it'll vary between that, how far you move the thumbstick left or right. It'll give you a bit more granular control over it because it's analog. But anyway, as I say, that's just another option. You can use the mouse as well, in fact, but that's not for now. You know what? Why not? Let's go mouse state, current mouse, and we'll get that from the mouse object. And player's position on the x-axis will be equal to the mouse's. Oops. Mouse's x coordinate. If we do that, you can see as I move the mouse left and right, so the pad. Oh, notice it lines up on the left-hand side though, because that coordinate is the first pixel of the basket. So that's if you want to use the mouse. I think that would make this game too easy though, so I'm going to take that out. So there's different control systems. Much time I'll be going for? I think we can probably put in some music, and then I'll leave it at that. Because I did have a MP3 file or two in there. MP3s are very slightly different because if you look on them in the content browser, MP3s are loaded in as songs, not sound effects. So we need to declare songs. So we're going to have a menu song, and we're going to have a game play song. It doesn't like that. Let's put in the namespace for it, media. And again, yeah, always the same. We want to go to load content, and our menu song, we load in a song from the content pipeline called, was it that groove, was it the name of it? I got these songs, by the way, from a site called gamesounds.xyz. We just collected a whole bunch of sound effects and music there. Gamesounds.xyz, it's brilliant, check it out. Anyway, that's our menu song, and our gameplay song is the other one, code blue. And we'll immediately start playing the menu song because we start in the menu. So that's done by using a built-in object called the media player. It's a static class actually, but tell the media player to play the menu song. That's all you got to do. Nice bit of smooth jazz. I just picked something quickly. Okay, so that's to play the menu song. What happens when you press space and you want to switch to the other song? Well, let's go to update startup. Press the space key down. We do all that usual stuff. Media player dot play gameplay song. Simple as that. You don't need to close down your old song because that's the whole point of media player. It's 4 songs and you don't have 2 songs playing at once like you might have with sound effects. So it will handle that for you. Intro song, and then we press space, you get the sound effect and switch to our game song. And we're just about ready to put the actual game mechanics in, but I think I'll leave that for the next video.